is the name of the game in this unit, but you see it in action and it starts to make more sense. All right, so I need the parent EBM. So here again is my A sub n. My B sub n if I divide these two things, I would get 1 over 4n. All right, that is not my B sub n. All right, so just kind of off on the side here, I'll just kind of chuck it. We have n to the 4th over 4n to the 5th. That's 1 over 4n. That is not the parent function. The parent function is the function that you would get if you stripped away any coefficients, any transformations, any horizontal or vertical movement, stretch, skew, anything like that. All right. So drop any coefficients, plus, and what you have then would be your parent EBM. I keep doing that. I want to put the summation symbol in there. So let me just give it a little wiggle room. All right. So again, first, or in this case, it's the first two terms, but the terms with the highest power, top and bottom, divide it. Drop any coefficients, and you have the parent EBM.
So if it was like 8 n to the 5th, still be 1 over n?
Yes. Yes. All right. So now what I need to do is find the limit. Oh, and by the way, this guy right here diverges by the P-series test, specifically the one where the p-value is between 0 and 1. I mean, if you just state that because p equals 1, that's fine. Now, so I know my n behavior model parent function is going to diverge. It's just a question of, well, does that mean that the original one is going to diverge? So that's where we apply the limit comparison test. I'm going to find the sum of, well, actually, I'm not going to write it as a sum. It's really just a sub n divided by b sub n. And we're going to find the limit as the n approaches infinity. And see if that exists. All right. Now the a sub n is that fun function. And my b sub n is the other one. All right, so a little housekeeping. Keep, change, flip. Would be the same as multiplying through on the top with an n. All right, so this would be n to the 5th plus 10. And on the bottom is going to stay as is. 4n to the 5th minus n to the 3rd plus 7. All right, so say it again. Oh, I forgot to multiply the 10 by the n. Thank you. Now the limit as n approaches infinity here would be the same as the limit of this n behavior model, so you really want to overdo it with this particular concept. Going back to Calc 1, so it's the limit of 1/4, which is 1/4. It's the same as finding the horizontal asymptote, right? I don't care what it is. I just need it to exist or not exist in order to answer my question here. So what that tells me is that, so therefore, that original summation of n to the 4th plus 10 over all that stuff on the bottom converges by the limit comparison test. All right. Oh, sorry, diverges. Diverges. I said it right in front of me, like right in front of my face. Whew. Cute. All right. So this limit comparison here is telling us that they're both going to converge or diverge, because we determined using the p-series test that this one diverges, they both must diverge.
If the limit did not exist,
Then this method fails. So then on to something else. All right, so next one, a little easier, I think. Here's my a sub n. The b sub n would just be the 1 over n cubed. And the sum, I don't know why. I don't know why I can't. It's the sum of n equals 1 to infinity of 1 over n cubed. Now that series in and of itself converges by the p-series test, specifically because we're looking for p-value greater than 1. Now I need to see how that's going to relate to the original summation and determine whether or not that's going to lead to convergence there. All right, so I'm going to do my a sub n over b sub n, so limit as n approaches infinity of 1 over n cubed minus 2 divided by 1 over n cubed. That's going to become the limit as n approaches infinity of n cubed over n cubed minus 1, minus 2, which after you apply your limit hocus pocus is going to give us a 1. All right. So this satisfies the limit comparison test, telling us that the two series, a sub n and b sub n, will either both converge or both diverge. Because we showed with the p-series test that b sub n converges, we now know that this series, and this should be a 2, will converge by the limit comparison test.